I am going to push record. Woohoo! Okay, so we are going to talk about arc length today. Arc is the part of a circumference of a circle. So as you can see, it's the little red part here. This is the arc. That's what we're going to talk about. We're going to find the length of this. Oh, why did it move? Hold on a second, because I did not lock it. Interesting. Okay. So we're going to find the length of this arc today, or any given arcs that are given to us. So we're going to find that length today. It also can be part of a curve. So remember, we graphed parabolas that look like this. So an arc can also be part of that, like this part. It could just be this part. That could be an arc. So it could be that. But right now we're talking about the arc on a circle. So I want to just differentiate the difference between it and let you know that there is an arc does not only have to be part of a circle. It can be part of any curve, but right now we're going to talk about the curve part of a curve of a circle. Okay, so arc length is the distance along the curve, part of the circumference of a circle or of any curve. And this is how we find it. So I just took this picture off instead of typing it. I thought it would be a little better. So we have, if you can imagine, you can kind of see it's dotted along here. So that's the circle continued. And they just took a piece of the pie out, like they just cut a piece of it out. So I have the center of my circle here and my measurement of my angle, which is theta. And then R, which is my radius, right? R is my radius, the distance from the center of my circle to the edge of the circle is radius. And they want me to find the arc length. So there's a couple different ways to measure it. If theta is measured in degrees, we're going to use this top one. And if theta is measured in radians, we're going to use the bottom equation. Well, how do I tell if they're in degrees or radians, right? How do I know what it's measured in? That's really the question. Well, it's pretty easy. If it's in degrees, it will probably say like 26 degrees. It'll have a little degree sign, right? That's in degrees. If it's in radians, it'll be like 3 pi over 4. It usually has a pi in it, right? And this would be radians. Remember when we converted from R-A-D-A-N-S, radians. Remember when we converted from degrees to radians and radians to degrees? Degrees have a degree sign and radians have a pi in there. Okay, so that's really the biggest difference between there. If there is not a pi in there, it will say radians. It'll say like 4 radians. Okay, or RAD. Then I need to, that will tell me which equation I'm going to use. Today, so you guys know, everything's in degrees. So we're just using the degree formula, which says this. It says arc length equals pi, which is my angle measurement, divided by 360. Times 2 pi r. Remember, the circumference of my circle was 2 pi r. So I'm going to take the circumference of my circle and multiply that by my angle divided by 360. 360 is the number of degrees in the circle. Okay, so I'm just going to take my circumference of my circle and multiply it by the angle divided by 360. So let's go ahead and try that right here. So I have my arc. They want to find the length of the marked arc. The marked arc is the dark, we can highlight this, is the dark part right here. If you go to number 2, you can see it's this dark part right here. In Delta Math, they may have it as a different color or just a darker color like this. I'm not sure. I'm sorry. I didn't really look at the problems before I assigned them because I just assigned, Miss Gilpin made the problem, so I just assigned the same assignment she did. So here we go. So I'm going to take 120, so my arc length, and I'm going to call it AL. Arc length is going to be 120 divided by 360 times 2 pi times my radius, which is 15. And then I am just going to put that in my calculator. And I'm going to get, I guess I need a calculator that actually has I don't think this one, I think this, I have to figure out which calculator to use. Because one of my calculators will only leave it in pi. So I'm just going to put it into my calculator as is. Was that Carlos that just came in? Oh, no, it was Walker. Okay, so I'm going to do in my calculator, if you use Desmos, that's fine, it doesn't matter. I'm going to do 120 divided by 360. Oops, let's do, I'm going to put it in parentheses. 120, oops, calculator, 120 divided by 360 times 2 pi times 15. And I get 31. So my arc length equals 31.42 centimeters. Okay? Questions? Does it make sense to you?
Yes.
Okay, great.
I just did it.
You got it all done already?
Mm-hmm.
Wow. Okay. All right, so we're going to do the same thing for number 2. Did they give you a picture of the circles?
Yeah.
Okay.
Like they gave the picture with the with like C, G, and H, and then it said like the thing up top like
Okay.
F and G is 7.
Yeah. Okay. So we've got 300 divided by 360 times 2 pi times my radius, which is 20 miles. Wow. 20. So my arc length is going to equal, or it's probably going to be approximately equal to, sorry. So 300 divided by 360 times 2 times pi times 20 is going to be 107.72 miles. And number 3, so we look at the dark circle, that angle is 195 degrees. So my arc length is going to equal, what is my arc length going to equal? 195 divided by 360. Remember, I'm just plugging into the equation. What does the equation say? The equation says I'm going to take theta divided by, 360 times 2 pi r. The only thing that I need to substitute in for is theta and r. So I'm going to look at my picture and find theta, which is here, and my radius, which is here, and substitute it in, and then plug it into your calculator. So times 2 pi times 9. And then that's approximately going to be equal to 30.63. I want to just double check that. Times 2 pi times 9. Yep, 30.63. Okay, is there any questions? Anybody at home have any questions so far? Are we doing okay? Awesome. So if we look at number 4, we're still doing the same thing. I'm going to write the equation up here so you guys remember. Arc length equals theta divided by 360 times 2 pi r. So I've got my angle, which is 90 degrees, and my radius, which is 11 kilometers. So I'm going to say my arc length is going to equal 90 divided by 360 times 2 pi times 11. So if I put that into my calculator, and when I'm putting it into my calculator, you guys, I'm putting this in parentheses. So I'm doing 90 divided by 360 times 2 times pi times 11, which is 17.28. Okay? Any questions so far? Anybody at home have any questions? I know you don't have any questions. Okay. He's going to miss the whole lesson. Okay, I've got my degree and I've got my my radius here, so I'm still going to do the same thing. So arc length is going to equal 150 divided by 360 times 2 pi times 14. So I've got 150 divided by 360 times 2 times pi times 14, which is 36.65 yards. Oh, I've been forgetting to put my measurements on there. So sorry, Carlos. Right, so the last one was kilometers. Don't forget your measurement on there. Okay, questions so far? Okay, number 6. Oh, there's the equation. I'm trying to keep the equation on here and be able to write. Okay, you guys can see it. So here's my angle, there's my theta, and there's my kilometers. So I've got arc length is going to equal 135 divided by 360 times 2 pi times 11. So I'm going to put that in my calculator just like that. So parenthesis 135 divided by 360 times 2 times 11. There we go. 25.92 kilometers. Okay. Now I have 6 problems I want you guys to try. I'll try and get them all on the screen here for you. I'll leave the equation up there so you can see it. So I want you to go ahead and put the answers. Anybody who puts... Okay, you guys, here we go. I'm just going to do these really quickly.
Why is it doing that?
So we've got AL equals 90 over 360 times 2 pi times 16 is approximately equal to 25.13 centimeters. Beautiful. For number B, yes.
So if it has 6.283, so I would have to round the second.
So just be 6.283, so it'd just be 28.
6.28?
Yeah, because the 3 is underneath 5.
Okay, I thought we were still like,
No, the 3 tells you if you're going to round it or not. The third number tells you if you're going to round it or not. So I've got 270 divided by 360 times 2 times pi times 12, which is approximately equal to 56.55 meters. Meters. Number C. The arc length is going to equal 315, 360.
times 2 pi times 14.
Which is approximately equal to
76.97 yards.
97 yards. Nice job, Ketland. Good job. After coming late, I know. Oh, Lord have mercy.
Oh, too much information.
Yes.
300 or 360 divided by 16 is approximately to 83.78 yards.
Almost a whole football field. That's how long that is, right? Because a football field is 100 yards, right? So this arc length is almost a whole football, only it's curved.
Yeah. Dang.
Thinking of it that way makes it like, yeah, dang, right?
Arc length equals 240 divided by 360 times 2 pi times 7 has approximately to 29.32 yards.
33 feet.
33. Oh, yeah. Actually, that's right. I meant to put 33.
And then
6 feet over 360 times 2 pi times 6 is approximately to 6.28 centimeters.
6.28 centimeters. Nice job.